I am Pavagada Manjunath, lecturer in physics. In this video clip, let us know what is crest, what is trough, what is amplitude, what is wavelength, what is frequency, and what is period of a wave. So now let us generate a wave in the medium. Look here, this is the wave in which particles are vibrating, and this disturbance is nothing but wave, and propagation of disturbance is nothing but propagation of wave or wave motion. So now let us know what is crest and trough. So here this portion, this is known as crest, and this portion is known as trough. One trough and one crest forms a wave. As the wave moves like this, the crest moves along with the wave, and also trough moves along with the wave. It doesn't mean that particles are moving along with the wave. We have already discussed that particles are not moving along with the wave, but they vibrate where they are. Now let us know about amplitude. Look here, this is the scale, and here this is 0, 1 unit, 2 unit, 3 units, like centimeter or 4 centimeter or millimeter, like this, and -1, -2, -3, like this. So now let us generate the wave. Look here, the particles jump to the 4 centimeter and they come back and jump to the -4 centimeter, like this. All the particles jump to the 4 centimeter height in positive direction and also in negative direction. So this maximum displacement of the particle from this mean position is known as amplitude. Let us discuss it by slow motion. So let us consider this green particle. It is displaced to 1 point something, 2 point something, 3, and look here, after reaching the 4 it turns its direction like this. I mean its maximum displacement is 4 centimeters in the positive direction, and also -4 in the negative direction. So like this. So this maximum displacement of the particle in positive direction or negative direction from mean position is known as amplitude. In this example, amplitude of this particle is 4. And now let us consider another example. So look here, in this case these particles are jumping to 2 centimeter height, and here the amplitude of this wave is 2 centimeter. It means all the particles jumps to +2 or -2. So the amplitude has to be taken positive, whether it jumps to negative maximum or positive maximum. So now it is one complete cycle or one vibration. Consider thread in its mean position. This is extreme position, this is negative extreme position. The thread is at mean position, starts to vibrate extreme and negative extreme and comes back. This is one complete cycle or one wave or one vibration. During one complete cycle, one trough is formed, one crest is formed. This one trough and crest is known as one wave. So for every one vibration, one wave is formed. Therefore, number of cycles or number of vibrations is equal to number of waves generated in the medium. Now let us know what is wavelength. So now look here, look at this green particle. Let it be disturbed like this in slow motion. It moves to the positive extreme position and coming back to the mean position, and again to the negative extreme position, and coming back to the mean position. Look here, this green particle has completed one wave. During this one wave, disturbance is propagated from ear to ear, and one trough and one crest is formed. This one crest and trough is known as one wave. Length of this one is known as wavelength. Look here, like this. Therefore, wavelength is the distance traveled by the disturbance in one cycle of vibration, or the distance between crest and consecutive crest, or trough and consecutive trough. Look here, it is like this. So here this is the crest and this is the consecutive crest. Look here, the distance between them is also equal to wavelength. Wavelength is represented by lambda. And this is the trough and trough. Distance between trough and trough is also equal to wavelength. And also look here, during this motion let us observe these two red particles. These two red particles are vibrating in same fashion. It means when this red particle moving up, at the same time it is also moving up. When it moves in the downward direction, it also moves in the downward direction. Now these two particles are said to be vibrating in phase. So the distance between such particles, look here like this, it is also equal to lambda, and that is one wavelength. Therefore we can also define wavelength like this. It is the distance between two consecutive particles which are vibrating in the same phase. Of course this one and this one are in same phase, this one and this one are in same phase. Therefore look here, the distance is lambda, and this one, this particle and this particle, these two particles are in same phase. Now let us know about frequency. Look here, these are the three threads and these are the three vibrators, and here there is a digital clock. Let us start to vibrate like this, and look here, it is 0.456 seconds, 0.9 second, 1 second. In 1 second, in this medium or in this thread, look here, 2 waves are produced. On this thread, 3 waves are produced. On this one, 4 waves are produced. Therefore number of waves produced per second is 2. This is known as frequency of this wave. On this wave, 3 waves are produced per second. This is the frequency of this wave. Therefore frequency is number of vibrations per second. Look here, number of vibrations per second, which is equal to number of waves. Therefore wave frequency is defined as number of waves set up in the medium per second. Look at 4 waves are produced. Therefore its frequency is 4 Hz. Hertz is the SI unit of frequency. Now let us see once again. So look here, this one is vibrating slowly, and this one is vibrating vigorously, and this one is vibrating moderately. Therefore its frequency is low and its frequency is higher and its frequency is moderate. And now let us take this length, wavelength. Look here, the distance between crest and crest is wavelength. Let us compare wavelength of this one with this one, second one. Look here, the wavelength of second one is less than first one, and wavelength of third one is still less than first one. It means as frequency increases, the wavelength decreases. So this is about frequency. Now let us know about period. So look here, it completes one cycle in certain time. This time is known as period. That is time taken by the particle to complete one cycle or one vibration is known as period. In one period, one wave is generated. In one period, the disturbance is propagated through this distance, and this is known as wavelength. So this is about frequency, period, wavelength, and amplitude.